Daniel and Jenny, are you back? Okay, so we are going to start a new chapter now. This is on page 86. Okay, this is called the exponent and logarithm. So exponent, you've been doing that for quite a while, several years, right? Ever since grade 8, you've been introduced to exponents, base, right? And how to evaluate. So today we are gonna learn a new term. Well, not today, in the next class, but today we're gonna just focus on exponent, okay? And then later, after we study exponent, we'll be looking at something called a logarithm. So yeah, so we finished, I think after exponent logarithm, okay, all the hard stuff in the grade 12, it will be done, okay? I put all the harder topics in book 1, okay? That's why we spend a lot of time in book 1. In book 2, which you already have, it's much easier, okay, than the ones we've been doing. We'll just quickly go over what's in this chapter. Right, so we start with a review on the exponent laws and then how to solve an equation that has exponents. And then we'll be looking at an exponential function. So function means we can graph them. Okay, so you can see we see some grids, right? Table of values. And then applications, how exponent can be applied to different, to represent growing of the money, right? Or representing anything that's slowing down, okay? Getting less, decreasing. So 2 parts, okay? One is function, one is equation for the exponent. And then we'll be introduced about to the logarithm. To learn what does log do, okay? Logarithm, we can just call it log. And same thing, we're gonna break it down into 2 parts. One is the log equation, and then we have the log functions. Okay, and then that will be all. So total 4 sections: exponent equation, exponential functions, log equations, log function. Okay, that's the layout of our chapter. So of course, let's start with something easy, right? Review of all the exponent laws that you learned before. If you have a lot of b multiplying together, okay? So everyone please turn to page 86 now. Then we can write it as b to the n. Okay? So the way we say it is we just say b to the nth power. So for example, b with a little 2, we say b to the 2nd power, or you can just say b squared. B to the 3rd power, or b cubed, right? And then after that is just b to the 4th, b to the 5th, right? B is called the base. N is the exponent. Okay, so you can write those down. And then we have a couple rules, okay, that we can go over quickly, which you've learned before. We start with the same base, okay? If you are multiplying 2 exponential expression multiplying together and they both have the same base, you need to add the exponents. Okay, you can see n plus n. If you are dividing, then you need to subtract the exponents, okay, to simplify. So you combine 2 bases together. And if you have a to the n, then you can multiply, okay? So make a note, okay, there is no rule for a to the n plus a to the n. Okay, this one, we don't have any rule, okay? Or subtract, okay? So if you want to find the answer for either add or subtract, you just need to find it separately, okay? So these ones has no laws, no exponential laws. Okay, only for multiply or divide. So let's simplify the right-hand side. Okay, so for example, the question A on the top, they are multiplying, so it will become 2 to the 15. Right, using the first law. The second one, the denominator, you can use the third law. Okay, 2 to the 4 to the 2 will become 8. And then we can subtract, right? They are dividing, it will become 2 to the 7. Okay, should be pretty easy, right? So the laws only work if they have the same base, right? They all have base of 2. So now please look at question B. Eric, do we have the same base for question B? Do we have same base for B, Eric?
We don't.
No, right? But what's that?
We have to change it.
Yeah, we need to change it. Okay, what will be the common base they can all change to?
It'd be 3, right?
Very good. Okay, so we need to change each one of them into base of 3. Okay, so 3 to the something, 3 to the something, 3 to the something. Okay, so I'll let you guys change them first. So please raise your hand after you made everything into base of 3. Well, the first bracket is already base of 3. I'll just copy it. Okay, so please change every single one into base of 3. All right, so Lily, what is the exponent for the second bracket on the top?
3 to the power of 4.
Yeah, very good. Okay, so it came from 3 square and then a square on the outside. All right, and Angela, what about denominator?
3 to the power of 3.
Very good. Okay, so after that, it's similar to the question we just finished, right? Like in question A, you could simplify everything together into just 3 to the something. Okay, so please also simplify this. Okay, raise your hand after you got the final answer. Okay, Nick, what's your final answer for this one?
Is my mic working right now?
Yep, it's working now.
3 to the 6th.
Very good. 3 to the 6. Okay, does anyone have questions how we got 3 to the 6? Please raise your hand if you got 3 to the 6. Right, so next part, is having the same exponent, okay? So if you look at the rule, if inside the bracket, you had more than one item, okay? You have the A, you also have the B, right? Then you can split it, share in the exponents to each of the item inside, okay? So you get A to the T, B to the T. So we call this rule the same exponent group. But make sure inside the brackets, you have more than one, right? Same with dividing, okay? So the law is only for multiply and divide, okay? Just like the first group. So if inside you have A divided by B, then the exponent on the outside will go into both of them. Okay, and make sure they are all in brackets. So I'll demonstrate the first one, right? So inside the question A, we have 2, we have the x squared, right? 2 things. So if you share in, you get 2 and x squared, and they both shares the exponent of 3. And then after that, 2 to the 3, we could evaluate into 8. Okay, don't write 6. Okay, 2 to the 3 is 8. And then multiply the exponent to x to the 6. Okay, using the third law. All right, so I'll let you try question B now. So think about how many items are inside you need to share. Okay, the exponent you are sharing in is the square. So please raise your hand after you found the final answer. All right, so please tell me how many base are inside we need to share. Well, how many things are inside the brackets? Do we need to share the exponent with? Okay, Marcus, how many things are inside?
Oh, sorry. 5.
Yeah, very good. Okay, so we have the -5, the x squared, the 2, the y, the z. Okay, please raise your hand if you have the final expression. Each of them gets the square. All right, Waylon, what's your final answer?
I got 5x to the power 4 squared z squared.
Okay, hold on. What is it?
5x to the power 4.
Like that?
25.
25, and then
And over y
square, and then
z squared.
z squared. Okay. All right, so anyone has questions about this one? Okay, so because the square also affects the negative, right? So -5 times -5 makes it positive, okay? So remember, if the negative is in the brackets, It'll be affected. Right, so next part is the zero exponent. Okay, so for if you have an exponent of 0, it just turns into 1. You can see question A and B, they are very similar. Right, one has bracket, one has no bracket. So you think about what does the exponent affect, okay? You have to figure out what's the base for the exponent. So if you look at question A, the base is a 2x, okay? And for question B, what do you think the base is? Philip, what's the base for question B?
Negative 2x.
Because there's no bracket, right? So
Yeah.
for the exponent of 0, the base is only for the x.
Oh, okay.
Okay, because when you have an exponent, it always carries a base, right? You cannot have an exponent without a base, right? You must have a number first. Let's say 5, and then you put an exponent at the corner. So let's say 3, right? So if there's no brackets, the only base that we have is the x. So exponent affects the base only. So for question A, the negative at the front is not part of the base, so it will just stay there all the time, okay? And then for the base, that's 2x because it has an exponent of 0, so it turns into 1. Okay? So whatever part that is not part of the base, it won't change. It won't be affected. So for question B, the negative 2 is not the base. So negative 2 will stay there. Okay? And then the base of the x will become 1. So times it by 1. Okay? So your final answer for B will be negative 2. Okay? Compare these two questions. One has brackets. So everything in brackets become 1. The other one doesn't have brackets. So only the x becomes 1. Okay? So that's the difference between brackets and not. Okay, next part is the negative exponents. Negative exponent makes it bring it over to the other side. So this one will become 2 to the 3 at the bottom. For B, it will go to the other side. So instead of going down, it will go up, okay? 3 doesn't have an exponent, so 3 will stay up there and then multiply with the 2 when it goes up. Okay, so you can try C and D. You just need to do the moving, okay? You don't need to evaluate, okay? Just show me how you move the bases, so then the exponents become positive. Okay, you can raise your hand if you finish both C and D. I think you learned the negative exponent in grade 10, right? And then grade 11, you learned about the fraction exponent. All right, Daniel, what's question C become?
I got 8/9.
Before evaluating, just leave it an exponent.
I just flipped it.
Yeah.
So it's 2 to the power 3 over 3 to the power 2.
Yeah, okay, just keep it an exponent, it's fine. Okay, if you finish D, please raise your hand. Question D, you need to think about law number 5, right? Because you have an exponent that's outside the brackets. Look at law number 5. Okay, what do we do for law number 5? All right, Waylon, what do you have for question D?
I got 27 over 8.
Okay, without evaluating, keep it an exponent.
3 to the power of 3 over 2 to the power of 3.
Yeah, very good. Okay, so everything on the inside flips, okay, because of the negative exponent shares n. Okay, from law number 5, -3 will share the exponent n. So they both get the negative to flip. Okay, of course you can, if they say evaluate, then you continue find the answer. Okay, last part. If you get a fraction exponent, it could be decimal, but if you get a decimal, you just turn it into fractions. So if you look at the rule here, the exponent, the denominator goes to the outside. Okay, the denominator goes to the outside. The outside number here is called the index. So denominator is the index. Okay, becomes the index. Index is the outside number, okay, outside the radical sign. So for example, 3 to the half, the denominator is 2. So 2 will become the index. So you can put a 2 there or make it invisible, it's fine, okay, and then 3 to the 1. Okay, and then same with this one, it will be 4. The index is 2, right, because denominator is 2, and then cube. Okay, right, so similar, can you please try questions C and D? Not just fraction, it also carries a negative, okay? So think about what to do if there's a negative. So of course, negative has to do with our law number 7. You don't need to evaluate, right? Just turn it into radical, okay? And then just leave it there, right? You can raise your hand after you get an answer for C and D. Okay, Callum, what do you have for question C?
Oh, so you put it 27, no, 1 over 27 to the power of 2 over 3. Then you square root of 3, which is 27. Square root, no, square root, cube root of 27 is 3, and then you square to the power of 2, so you get 9.
Yeah, okay, we don't need to evaluate, you just need to turn it into radicals, cube root, and a square. So like you said, if you want to evaluate, it will become 1 over 9, okay? So leave the answer like this, okay? Just practice how to turn it into radicals. So if the index is 3, we call the cube root, okay? It's not the square root. If the index is 4, we call it the fourth root, okay? If it's 2, we call it square root. Right, question D. If you got your expression for D, please raise your hand. So of course, this one you cannot evaluate, right? You have an X there. Okay, Chris, what do you have?
4 over square root of x.
Yeah, very good. Okay. So the 4, look at this one, is similar to, what is it? Like question B in the third rule, the 0 exponent, right? It has no brackets. So the base is only X, no brackets, right? So only X carries the exponent. So the 4 has to stay up there, okay? Only X flip over. Okay, everything up to here should be a review, okay? If you have forgotten, I hope this helps you to remember what you learned before, because we're gonna apply these law, okay, from time to time to solve equation, okay? So we're gonna move on to our next page, okay? Can you raise your hand if you're ready to move on, if you got everything here? Make sure you have all the rules copied down. Okay, Caleb and Chris, do you need more time? All right, so let's look at next page now. So this page is to solve exponential equation. When you start solving equations, when they say solve, means to find x. Okay, equation means you have left and right side that equal each other. And this method is called solve it by same base. Okay, we did something similar before, like on the last page up here. Right, we have base of 3, base of 9, base 10. They all have different base, right? But then they common base that we can all change to. Like 9, we can turn it into 3 squared, right? 27 turn into 3 cubed. Okay, so that's called same base. So if you don't have same base, you can make them the same. Right, so we are looking for the value of x so that it can make the left side equal to the right side. So you start by looking at the two bases. Okay, you have a base of 4, base of 8. So what is the same base that we can change them to? Angela? What's the base that we can change them?
2.
2, very good. Okay, so 4 can become 2 squared, right? You can write it on the side. The 8 can become 2 cubed. Okay, so let's do that, right? So we change them into 4 become 2 squared. You have an x. 8 become 2 cubed. Okay. So this, the green circle, the thing I circle in the green, those are exponent, okay? Whenever you put it at the, make sure you don't write it too big. Otherwise, it will look like a base, right? So please make sure when you're doing your work, your exponent don't write like this. Okay, it will be very confusing for yourself too, right? Make sure you write smaller at the corner. And then now we use our exponent law to simplify it. You have 2 and the x. They are both exponents, so we could use the third one, turning the 2 to the 2x. Now for the right side, same thing. Okay, we have exponent of 3, exponent of 1/3x plus 1. Okay, we could also simplify that. It will become 2 to the what? Okay, can you please raise your hand if you have the exponent on the right side? Okay. Okay, Jocelyn, what's the exponent on the right side? Jocelyn? Jocelyn, you need to turn on the mic. Yeah, do you have the exponent?
3.
Hmm? What did you say?
3.
3? How did you get 3? How did you get 3?
Wait.
What do you need to do? Are you there, Jocelyn?
Yeah.
Yeah, okay. How did you get the 3? You need to multiply the 3 with 1/3x plus 1. Do you know how to multiply them?
Yeah.
Okay. How do we do that? Hello?
Just multiply by like 1/3.
Yeah, what do you get? What's 3 times 1/3?
Uh
Do you know how to take 3 times 1/3?
the 3/9.
3/3. You only multiply the numerator. Okay? You know what's 3/3?
Yeah.
What's that? What's 3/3?
1.
Yeah, so 1x, okay? And then plus what? 3 needs to times the 1 now. What do you get?
Yeah.
What is
3x. 3x.
3 times 1?
3.
Yes. Okay. So you get 1x plus 3. Okay, very good. So the right-hand side simplified into 2 to the x plus 3. Okay, left-hand side is 2 to the 2x. The both sides should equal each other, right? Now the base are already the same. Okay, you please write this down. You have one base on each side. After you have one base on each side, then you can drop the base. Okay, you can ignore the base because the base are the same now. All you care right now is to make the exponent the same. Okay, so you take away the base, just focus on the exponent. So the exponent on the left should equal to the exponent on the right. So this is called drop the base. Okay, drop the base. The two bases, okay? The base on each side. This step, okay? So first you must make sure you only have one base on each side. Once you get here, right? Once the base are gone, you just solve for x. You can move the x over, right? So you get x equal to 3. So that's your answer. So if you plug the 3 back into the question, it should be able to make the left side equal to the right side. Okay, so for example, if you have 2 to the x plus 2 to the 3 equal to 2 to the 7x. If you get something like this, even though everything the same base, I cannot drop, okay? You cannot pull away and then say x plus 3 equal to 7x. So this is wrong. You drop the base too early, okay? So you need to simplify it before you can drop it. Or something like this, okay? If it's multiplying and then you roll down, right? And you roll 3x equal to 7x. This is also wrong, okay? So you need to simplify it first into one base. Make sure you have one base on each side before you drop. Okay, and it has to be the same base, okay? One side is 2, the other side has to be base of 2 as well. All right, so let's try question B. What's the same base that we should change to this time? Philip?
5.
Yes, okay. You have on the left side, you have base of 5. The other side, you have a 1 over 25, right? But then 25 has to do with the 5, right? So somehow, after a few steps, you should have 5 to the something equal to 5 to the something. Okay, before you can drop the base. All right, so remember, don't drop it too early. All right, so I'll let you guys try this out. All right, so once you get to this step, same base on each side, please raise your hand or check your exponents. Okay. So left side has a square root. So think about the law that we review. Okay, what's the law for having a square root? How do we turn that into exponent? And then on the right side, we have a fraction, right? 1 over 25. How do we turn it into exponent? Okay, let's check the left-hand side first. Caleb, do you have the left-hand side, the exponent for the left?
No, I don't.
For square root, how do you change square root into exponent?
You square it by 2? I'm not so sure.
Okay, let me ask you this way, okay? If I have square root of 5, how do you write that as exponent?
Sorry. 5 to the power of 1 over 2.
Yeah, so we want to rewrite it so it become exponent, okay? So your left side, whatever that's inside, underneath, just keep it there, okay? And then the square root part, I'll use a red, okay? The square root part becomes the 1 over 2. Understand?
Okay.
Okay, so you rewrite it backwards, right? Before was before was they give you the exponent of 1 over 2, you write it as radical square root. Now you go backwards, write it as exponent. Okay, let's look at right hand side. Eric, do you have the exponent for the right hand side?
-2.
Very good. Okay, so let's let me show the step a little bit more. Okay, 25 you can write it as 5 squared, so 1 over 5 squared, and then you bring it up, you become -2. Okay, let's move this up. Okay, and then on the left side, the third law, 2x minus 3 and then 1 over 2, they are both exponents, so we could multiply it. Okay, so Sophie, what does it become on the left side?
Sorry, can you hear me now?
Yeah, I can hear you now.
Okay, could you repeat the question again? My mic was breaking out.
Yeah, so what's the exponent on the left side after you simplify?
After you simplify, it's 2x over 2, which is just x, and then minus 3 over 2.
Yeah, okay, so you're multiplying the 1 over 2 into the exponent. So 1 over 2 times 2x, 1 over 2 times the 3. And then you look at the left side, right side, they only have one base, right? Now we can drop, okay? Drop the base, just focus on the exponent now. The exponent on the left should equal to the exponent on the right side. Okay, ignore the base. So from here, solve for x. All right, so please solve for x. After you found the answer for x, please raise your hand. Okay, you should have the answer by now. This is just one step, okay? Solve for x. Angela, do you have the answer for x?
Is it -1 over 2?
Yep, very good. Okay, you just move the -3 over 2 to the right side, okay? Combine it. All right, so we are going to try 2 more questions. Okay, question A and B. Let's start with A. So I'll leave this one to you. Okay, A is looks just like question A on the top, right? Very simple, I hope. Okay, so think about what the base we should change to. We'll check the answer for A before we do B, right? B is more complicated. So you can go all the way now, okay? So try it out, see if you can get the X. Once you found the X, you can raise your hand. This, for this answer, for this question is a fraction, okay? Either a fraction or decimal. And if you are pretty confident about this answer, you can move on to B, okay? You can start on question B. If you're not quite sure if you did it right, then you can wait after we go over that. Okay, let's check the base first. Okay, what should be the common base for this one? Jenny?
3.
Yeah, very good. So make sure you change both sides into base of 3. Okay, and we'll check inside the brackets. Marcus, what's inside the left bracket? 3 to the what?
It is x minus 1.
Yeah, x minus 1 is on the outside, but we changed the 81, right? 81 into base of 3. What's that equal?
What is it, 9? Wait,
To the 9 is 81.
wait. I don't know.
You have to try, right? You try 3 times 3. Is that 81?
No.
and then keep going, right? Times 3 is that 81, right? Keep on trying until you get 81.
Wait, is it 4?
4,
Yeah,
okay. 3 times 3 times 3 times 3, right?
yeah.
Okay. So you do the same thing for the 1/27. 3 to the what? Will
Oh,
become
3 to the 3.
yeah, 3 to the -3. Very good. Okay. And then keep on simplifying. You need to get to the point when you have one base and one exponent. Okay, one base, one exponent before you can drop. Okay, if you already got the final answer, please raise your hand. Okay, Sophie, what's your final answer for X?
My final answer for x is -4/5.
-4/5. Okay. And Callum, what's your final answer?
Same as the first one.
So -4/5.
Yes.
Okay. Waylon, how about you?
Can you repeat yourself? Kind of cut up.
Yeah, what's your answer for A?
4 over 5. I mean 1.6.
1.6. 1.6. What's that in fraction then? Is that 4/5?
1/6. I think it's. Yeah, let me see. I think it's 10 over 8. Wait, 1 sec. 8 over 5.
8/5. 16/10, right? 8/5. Okay, so we have -4/5, 8/5. Eric, what about you? Eric?
I had a mouthful of water. I got 8/5 as well.
Okay, we have a tie here. Okay, so let's check. So for the left side, we need to multiply the exponent. So 4x minus 4. Okay, for the right hand side, you multiply the exponent, you get -6x plus 12. Because negative times negative, right? Give you positive 12. So now you can drop the base. Left exponent should equal to the right side exponent. And this is just a simple moving around, isolating the x. You move all the x to the left, move the number to the right side. So you should have 10x, right? Because you add a 6x, and then you add a 4, you get 16. Okay, and you divide both sides by 10, so you get 16/10. If you reduce that, then you should have 8/5. Okay, so be careful when you are moving things around. Sophie, where was the mistake that you did? Because you and Caleb got the same answer.
I'm pretty sure I got the negative sign wrong and like I flipped it.
Yeah, okay. So yeah, when you multiply the negatives or moving thing to the other side, make sure to change sign. Okay, we need to do one more. Okay, question B. Maybe some of you already started. So this one, the 9, the 3, 27, 81, okay? We all know the base has to be 3. And it has quite a few exponents, right? Quite a lot of exponents. So for the 9, and the 3, and the 27, and 81. Okay, those 4 bases you need to change. Okay, I'll let you try it out first. If you already have the final answer, you can raise your hand. Oh, already have 3 people done, finished. Okay, so each of the red number, you need to turn into base of 3. So 9 will be 3 squared. 3 is just 3. 27 is 3 cubed. And then you still have the exponents. $81 from our last question, we know it's 3 to the 4th. Okay, we still have a lot of bases, right, on the left side, so cannot drop the base yet. Who's not here? Someone dropped off. Jocelyn? Jocelyn not here, right? Jocelyn? All right, so let's check the exponent on the numerator first, all right? We have a few answers already. Okay, Daniel, what's your final answer?
I got 1.
All right. And Claire, how about you?
I got 3.
Okay. It all sounds nice. Integers, right? Sophie, what's your answer?
I also got 1.
Okay. Lily?
I got 3.
Oh, okay, another tie. All right, let's have a tiebreaker. Nick, what's your answer? Nick,
Sorry, could you repeat your question?
what's your answer?
I got 3 to the 12.
3 to the 12 for x. Is that
Oh, no. No, I got 3.
oh, 3? Okay. Okay, let's go over. Okay, we'll go over. You have, yeah, either 3 or 1, right? Let's get one more. Okay, Susan, what about you?
I got it wrong.
What do you have?
Definitely not the right answer.
You have a fraction?
Yes,
It's okay. Sometimes it could be fractions, right? That last question.
it's definitely wrong.
Okay.
Yeah.
It's okay. Yeah, we'll go over it, right? Waylon, how about you? Do you have an integer or fraction?
Oh, I got a fraction as well.
Okay, right. Looks like we need to go over this. You have a question like this on the homework, okay? So on the top left corner, the top left brackets, you have 3 exponents, right? The 2, 2x minus 3, and the 3. So all those exponents you need to multiply together, okay? So what I would do is I multiply the 2 and 3 first. That makes 6, okay? So 6 will multiply in, makes it 12x minus 18. Does anyone have questions so far? How we get that? And then on the right brackets, okay, it will become 3 to the 6x. That one has no problem, right? Pretty easy. Similar for the denominator, okay? We have 3 exponents. So Susan, can you tell us after you multiply those 3, what do you get? For the denominator?
3 to the power of 12x minus 24.
Yeah, very good. 12x minus 24. Okay, so 4 times 3 and then times it by the x minus 2. You can multiply either way. Okay, you should end up the same. Right hand side 3 to the 12. That part is fine. So still, you cannot drop the base yet. Okay, it's too early to drop it. You need to simplify. The common mistake is to have it like 12x minus 18 and then times it by 6x over 12x minus 24. Okay, this is the common mistake I see. Okay, so you cannot do that. On the numerator, they are multiplying, so your exponent you should add. Okay, on the top will be 12x minus 18, add with 6x. And then the bottom part, because it's dividing, so you should do subtraction. Now, when you subtract, that this is another common mistake, is to have no brackets. This will be wrong, okay? You need to subtract the whole exponent at the bottom because it will affect the sign when you are subtracting. Adding is fine, okay? But subtracting, you have to be very careful. Okay, equals to 3 to the 12. Okay, there's still one more step to do. So we need to simplify the left side now. The 12x can cancel with the 12x, right? Because they're subtracting. So, and then the Okay, we'll write that down first. So you're only left with 6x. And then you have negative 18 minus negative 24. Negative 18 minus negative 24. Waylon, can you tell us what that equals?
Equals negative 42.
Negative 18 minus negative 24.
Oh wait, my bad. 6.
Yeah, so it becomes 6. So this is combining all the like terms, okay? And then that should equal to 3 to the 12, okay? Now each side has one base, one exponent, right? Then we can drop the base, okay? We don't have space now. 6x plus 6 equal 12. You move things over. 6x equals 6. X should be 1. Okay? Well, let's not draw the arrow, okay? So be careful with simplifying the exponents. Okay, changing the same base is easy, but simplifying little things you have to watch out. Okay, we have a spring break coming up. Okay, so our next class is actually April, let me see, April 2nd. Okay, so please make a note. So almost a month, right? A month break. So during the break, I'll be giving you homework on these kind of questions with exponents and some review question on the trig, okay? So the amount will be about 1.5 weeks of homework, okay? A little bit more than usual, but not too much, okay? So you still get to enjoy your spring break, okay? And if you have questions, you can stay after class. And please hand in your homework before you leave today. All right. And you guys enjoy your spring break.
Thank you, Jason.
Okay. You're welcome.
you.
Thank you.
Thank you.
Bye.
Bye.
All right, Eric, do you have questions?